Okay, so the Pythagorean theorem word problems. When do we combine and when do we subtract? Tell me which one, talk with your shoulder partner and tell me which one you add, which one you subtract. Alright, 5, 4, 3, 2, 1. So for this one, what would I do? Add. So that would be c squared equals, we would square both the small legs to get the total.
Yes.
What if I want to find this one? What would I do?
Find the short side. Short leg.
The short side means you subtract. So that would be c squared minus what? A squared equals what? B squared. Correct? Okay. Pencils down. A tent is supported by a guy rope. Shh, guys, I need you to calm down. A tent is supported by a guy rope tied to a stake. So here is the stake. Here's the guy rope, as shown in the diagram. What is the length of the rope? So this is the pole right here. This is the rope, right? Or no, it's not even rope. It's just the distance away from the ground. And then here is the rope. So let's make sense of the problem first. What am I trying to find? I'm trying to find C. In order to find C, would I add or would I subtract? I would add. So I would use C squared equals A squared plus B squared. So that would be 8 squared plus 6 squared. So C squared equals 64 plus 36. Most of you, from doing what we did already, should be able to just see it and figure it out right away without even an equation, right? You should just say, oh, that's 64 and 36. 64 and 36 is 100. That side is 10. That was the whole point of me doing this with you drawing pictures. Okay? So C squared equals 100. I don't even care if you do that much work for these. If you can go right to 64 plus 36 and tell me C is 10, you know what you're doing. Okay? So if I take the square root of both sides, C equals 10 feet. All right, copy that down. All right, here's the next one. If the supporting stake in problem 1 were 15 feet, so if this were 15 feet, oh, no, supporting stake, 15 feet from the tent, that would go here. Part of these is just figuring out what it's saying, right? And an 8-foot tent pole were used, so this is 8 feet. What would be the length of the rope? You guys do that one. Do one. Okay, so you guys said you had to add or subtract, combine or subtract. Add. So I would say C squared equals 15 squared plus 8 squared. Off the top of your head, do you know what 15 squared is? 225 plus 64. What is 225 plus 64? 289? Well, that's nice because I know that's a perfect square.
Oh, really? Is it 14?
Well, if 15 is 225, 17. All right, let's talk about that for a second, guys. If you know some of your squares, listen up. Let's just take this here. If you know some of your squares already, so you guys should all know at least 12, right? So if 12 squared is 144, what is 2 times 2?
4.
You see how it ends in 4?
Yeah.
13 squared.
169.
169. It's easy for that one to be remembered, right? Okay. 3 squared. 3 squared is 9. Let me show you something really cool. 14 squared is 169 transposed, 196. Which 15 squared is what? What's 5 times 5? Add a 2 in front of it.
Wow.
16 squared is going to be a little bit more than 225, but it's going to end in a what? In a 6. What do you think it is? No, it can't be that close. 256. 17 squared, what is 7 going to end with?
9. 29.
See how it's 1 less? 8 is 1 less than 9. 5 is 1 less than 6. See that? 18 squared. All right, so we know it's not going to be in the 2s. It's got to be a 3, right? And what's it going to end with? 8 times 8 is, look at this, 8 times 3 is 24. 19 squared. It's going to be a 3. 9 times 9 is, it's going to be higher than that, right? 361. That one's not very special. Except for, what's 20 squared? 400. Isn't 6 kind of in between 2 and 10? Right? If you were looking at it that way. All right, let's go back. So what's the square root of 289? You think, okay, what number ends in a 9, Jesse, when you multiply it by itself? What number ends in a 9? 7. So it's probably 17. See how I did that? So 17 feet. Solve in sense. Does 17 make sense? If this side's 15 and that's 8, does 17 make sense? Yes. All right. Try this one, guys. Let's make, it says Stephanie is planning a right triangular garden. She marked 2 sides that measure 24 feet and 25 feet. What's the length of the nth side? Let's put n here. Let's make this side 24 and this side 25. You guys do that one for me. All right, so since I'm going to be subtracting, trying to find the smaller side, we're going to say c squared minus a squared equals b squared. Does it really matter which one's b squared and which one's a squared? No. We're just going to say the larger side, which is 25 squared, minus the smaller side, which is 24 squared, equals, we could call it n squared. Let's do that. What's 25 squared? 625. We know that the 24 squared is going to end in a what? A 6. It's probably not going to be a 6. It's going to be a 5. 576. What is 625 minus 576? 49. So you should immediately be able to tell me what that side is. 7. Does it make sense? It does make perfectly good sense. You know why? Check this out. If you had a garden that was that long on this side and this long on this side, wouldn't this piece have to be really small? All right. Questions? Are we good? All right. A builder needs to add diagonal braces to a wall. I really like this picture a lot because it describes the stuff that my husband talks to me. He's always talking about the top plate and the bottom plate, but honestly, I just knew something was on top and something was on the bottom. I didn't realize it was that wood piece that's right there. Now I know. And these are called noggings. Don't you think he's going to be impressed when I go home tonight and say, hey, how far apart do you normally separate the noggings? Right? Because who would know what a nogging is except for somebody who's in construction? All right, so when you're building a wall like this, I know because my house had a lot of these just recently, but when you're building a house like this, and you put noggings in between the studs, you need a diagonal for support. So it's asking us if a builder needs to add diagonal braces to a wall. The wall is 16 feet wide and 12 feet high. What is the length of each brace? What would I use? What am I trying to find? The C, right? If this is a triangle, that is a horrible line. Let's see if it gives me a straight one. Oh, look at that. Isn't that beautiful? So if it gave me 16 and 12, aren't I finding C? So am I going to combine or subtract? Guys, so if you want to find C, combine. If you want to find the small side, you subtract. See how they match? Small, subtract, C, combine. Okay. So C squared equals A squared plus B squared, or I should just say 12 squared plus 16 squared. Let's see if you guys can do this one. What's 12 squared? What does 6 squared end in? Maybe in the 2's. What do you think? 5, 256, right? What is 144 plus 256? 400? So what's the square root of 400? 20. Make sure you write that down. All right, so let's read this one very carefully. I want you guys to do this on your own. Forget the whiteboard part. The diagram at the right shows how a post was broken. So see how it used to be a really tall post here? Jesse. Focus. Right? If you had a post and it broke, you could figure out how tall the post is, right? Let's say it's so heavy that you can't pick it up and put it up and see how much.
It's only 2 feet.
Yeah, exactly. It's really, really, really heavy. Got it? All right, so, no, it's not 2 feet. We don't know how tall it was before.
Oh, we're going to find out.
We're going to find.
Right now, we know how tall it is right now.
Yes. What it was before.
Shut up.
Because if you were to take the piece and stand it back up, stop, please calm down. If you were to find this right here, you'd be able to stand it up and then add it together, right? Well, here's another thing. This is measured in inches. This is measured in feet.
2 feet is 24.
2 feet is 24 inches. Okay, you guys work it out. Remember, you need the total. All right, so what you guys come up with, are we going to combine to find C, or are we going to subtract? We're going to combine. We realize this is 24 inches, so we're going to say C squared equals 18 squared plus 24 squared. We've already found these two values, right? What is 18 squared? 324. What is 24 squared? 576. What are those two added together? 900. So if C squared is 900, if the area of C is 900, what is the side of C? 30. So if I were to stand this up, this would be 30. So 30 inches plus 24 inches makes how many inches? 54 inches. How much is 54 inches? 4 feet would make 48 inches. How much would you have left over? 4.5 feet. questions? I'm going to post for it then. Yes, ma'am. Because 2 feet is 24 inches. And this is in inches and this is in feet. Or you could have done 1.5 feet, but 1.5 feet is not going to be fun. Right? Alrighty. You guys ready?
I'm ready.
Okay, what did you learn today?
I learned that in my game that we decided like
Pythagorean theorem with word problems. Please give me your attention. When do you subtract when finding... Guys! When do you subtract when finding the length of a side right triangle? When do you subtract? When you're trying to find the shorter side, you subtract. Good. On your assignment sheet, the sets of numbers 3, 4, 5, and 5, 12, 13 are examples of Pythagorean triples. How do we know? Because 3 squared plus 4 squared equals 5 squared, does it? 9 plus 16 equals 25?
that is true.
Does 5 and 12 and 13 work? Let's see, that would be 25 plus 144. Does that equal 169?
It does.
Check this out. What if I were to take 3, 4, 5 and make 3, 4, 5 twice as big? What would the 3 side be? Do you guys understand what I just said? If you're trying to make 3, 4, 5 twice as big, how big would the side of 3 be? No, twice as big. 6. And the 4 side? 8. And the 5 side? Does that one work? 36 plus 64. Does 36 and 64 make 100?
Yeah.
Let's make it 3 times as big. It would be 9, what? 12 and 15. Does that work? 81 plus 144 make 225. Are you guys seeing what's happening, the pattern?
Yeah.
Jesse, turn around. I want to ask you directly. Okay? Do you see how 3 squared plus 4 squared equals 5 squared?
Yeah.
If I multiply each one of these numbers by 2, wouldn't I get 6, 8, and 10?
Yeah.
See how that works? If I were to multiply each one of these numbers by 3, wouldn't I get 9, 12, and 15? See how that works? So give me another triple. 18, 24, and 30. What's another one? How about 30, 40, 50? Would that work? Do you see how you can use triples in this way? Right? Okay, good job, guys. Let me give you your homework.